In section 5.2, we look at a particular random variable that can be modeled by the binomial probability distribution. And this particular distribution has a lot of different uses, and it models a case where we know that there are two possible outcomes, and we can usually classify these two possible outcomes as success and failure. And we can perform this experiment multiple times, and each of those multiple trials are going to be independent. And with that in mind, what does the binomial probability represent? And there are essentially a lot of different ways that we could think about it. And we'll first introduce the notation here below. So the notation that will be important, we will use the letter N for the number of trials. P is the probability of success. Q is the probability of failure. So oftentimes we can just think of Q as 1 minus the probability of success. And X would be a specific number of successes that we're looking to understand in our probability distribution, where P of X here is the probability of exactly X successes in our N trials. Okay, so now let's think of some examples that can be modeled by this. One is this example where, according to Wikipedia, 19% of Mexican residents are vegetarians. If we randomly survey 20 Mexican residents, what's the probability that exactly 3 of them are vegetarians? So this question, for example, here can be modeled with a binomial probability distribution. And we'll look at it this way. There's two possible outcomes when we're surveying, or we're asking these 20 people whether or not they're vegetarian. So either they're vegetarian or they're not vegetarian. And we can say, okay, if they're vegetarian, then we'll call that something that occurs with a probability of P. And in this case, since we know 19% of Mexican residents are vegetarian, P would be 0.19. Okay, and Q would be 1 minus that. So Q would be 0.81. Since we're surveying 20 people, and we'll be 20, and we're asking ourselves, what's the probability that exactly 3 of them are vegetarian? So X would be 3. So here we've kind of labeled everything that we need. One form of the formula for this particular distribution looks like this, where we've got this formula for N choose X. Essentially tells us all the different ways that we could choose X objects from N. So it's a counting method. And then P to the power of X times Q to the power of N minus X. That would be P times the number of successes, or sorry, P raised to the power of the number of successes. So P times itself, however many times you expect there to be a success, and then Q times itself, however many times you expect there to be a failure. Now, in most cases, though, we can stick with our graphing calculator to compute this formula for us. So we can just simply evaluate this function on our calculator, the binom PDF. And the way we can access that is through the distribution button on our calculator. And for most of the examples I'm going to do, this will be the way I'll prefer to do it, is instead of using our binomial distribution formula as it's written above, we'll just stick with the calculator function under the distributions menu. So in the next example, we'll see how that's done, which again here, use the problem from above regarding the vegetarianism in Mexico to set up and evaluate using both methods. Well, let's start with the P of x formula here. We're looking for P of 3. We had 20, choose 3 times Q, P, our probability of success was 0.19 to the power of 3 times Q, which was 0.81 to the power of 17. This button can be also calculated in using your calculator. The way you would find that is using the probability menu on your calculator. And so you can punch all that stuff into your calculator, and that would give you the result in one way. But here, let's look at the result using the Binom PDF. And in this case, the parameters that we're putting in, we have 20 trials, 0.19 was our probability of success, and we're looking for exactly 3 successes. And so this will actually give us the same result whichever way we do it. So about 0.217 when we do it either way. In my opinion, if we get comfortable doing it this way, that's going to be faster and easier to punch into our calculator.